Hello, everyone. I hope you're doing well and you're fit and fine, coding, preparing for placement, internships, your first year, second year, and any year. And if you're new to the channel, make sure to hit the subscribe button and hit the like button on the video because we prepare content around tech, DSA, interviews, placements, and all right. And we're coming with a whole preparation of your placement series, and also we started a recently OA series for your online assessment preparation. The link is in the description of the playlist. Do check it out. There's a very plenty of good resources available there. And I would be coming with many good things. Like I have also uploaded LinkedIn and resume building things on my channel. So do check it out. And yeah, do let me know what should I make further in the comment section. Right. And I love your comments. You're commenting too well. Keep commenting, keep learning, guys. Okay. This question today comes replace non-coprime numbers in the array. As we all know, our job is to convert and remove this fear of hard to easy. And actually, if I say this question, this is you can say easy to medium, but it would be easy to medium. It's not difficult at all. We will try to convert into easier side more, still medium because sometimes it happens, right? Some intuition is important. Once you got the intuition, it becomes easy. The intuition coming is thinking is medium, and okay, fair enough. So let's try to understand and read the problem statement properly because I just want to remove your fear of this hard question. It is not at all hard, right? And I'll also show you before giving a disclaimer that what I initially submitted a wrong answer. I am pretty sure about it. Most of you will solve in the similar way. You got a wrong answer, then you hit back what to do now. So yeah, I was because I just want this type of learning only when I commit mistake. I told you that what mistake you can also commit, and then we'll try to learn from that because it's not about solution. It's about learning the intuition. How we reach the solution is a major learning. Solution is just a part of the process, right? You is a byproduct. You're given an array of integer nums. Perform the following steps. Find any two adjacent number in the nums that are non-coprime. Okay, you know coprime numbers, right? Their GCD is 1, GCD of AB. What is GCD? Means there is a common factor between, let's say, 2 and 3. The GCD is 1, but the 2 and 4, the GCD is talking about GCD here. Fine. The not no non-coprime means uh, could be there should be at least some GCD, right? 2, 4 are not non-coprime numbers. Okay. If no such number are found, stop the process. Fine. Otherwise, delete those two numbers and replace them with the LCM of the numbers. Okay. What is LCM here? LCM is nothing but the least common multiple. What is the LCM of 3 and 6? Tell me. You remember from your school days, right? Least common multiple, it's 6 only. Okay. Then 9 and 12, what is the least common multiple? 18. Right. So this is how you remember your school days. And we'll also see a school days property that will eventually help to solve this problem as well. Stay tuned. Repeat this process as long you can keep finding two adjacent non-coprime numbers and return the final modified array. So you don't need to do something. You have to apply these operation itself. Sometimes, see, when you see this problem, right, you should think, oh, I need to calculate some minimum operations, final size, even modified size only. So we can do it. So if it, the problem had been, don't return me the array, just return me the final size. Think about the size term. Don't think about modifying the actual array, but here they already told you have to return the modified array, means it is possible to return the array. That's how you also change your thinking process as well, according to the question. It may trick you, but it will help you as well, most of the time. It can be shown that replacing all adjacent non-comparative number in arbitrary order, you will lead to same. So they are ensuring you that whatever operation you do, the modifier array will always be same. The test case are generated, final array less than equals to 10 power 8. That's fine. Two values, x and y are non-coprime. There's also a trick thing that told you this thing. This will eventually happen, but we have to use long and I will tell you why. So yeah, it could also one of the issues that in your code as well. So two values, x and y are non-coprime. GCD, it is common divisor, x and y. Okay. Cool, fair enough. So let's try to see this with the help of this example. Then we'll try to derive the intuition that what is wrong in our approach, that what I initially thought. And yeah, so 643. 6, okay, fine, no problem. 6, so we will do something with 6. Then I approach a 4. Oh, I can merge them, right? So it becomes what, 12? Okay, we move forward. Oh, 3 I can also merge them. It is again become 12 only because the LCM of 12 and 3 is 3 only. 12. Now I come to 2. Oh, 2 I can also merge in this only. So this will be 12. Fine. But I reach 7. Oh, now 12 and 7 is no common factor, right? So I need to push 12 and then I will start my new number with 7. I won't push it. I pushed 12 and then I am waiting for 7 to find its factors. Oh, I found 6. Oh, no, 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 I cannot do that. I pushed 7 as well, and then I will start iterating from 6. Oh, 2 came. Oh, it's fine. 2 will push it at the end. When nothing remains, I will push the last element itself, and then this is the out. So when you see and solve in this intuitive manner, what do you observe? You observe, oh, it's a very simple question. Yeah, no thinking. Apply a pref variable, start with the first element, nums of 0. Keep checking, keep checking. The pref and current GCD. What is current? Nums of I only. Nums of I GCD. And if it is greater than 1, then update the pref. Means sort of the GCD equals to 1, that would be a blockage. So that will divide these into the parts, and then you push this into one thing, you push this into one thing, and you push this into one thing. And this is the points where you are finding GCD equals to 1. Update the pref, else push the pref, and reset the pref to cur. Reset pref equals to nums. And this is a very simple solution, right? And indeed, this is was the simple solution I thought of, that you can do that. Also, one more thing, how do you calculate LCM of the numbers? So I hope you remember this property, that LCM into HCF or GCD are same only. Don't confuse with them. Is equals to product of two numbers. Let's say x1 x into y. So you can calculate LCM by knowing the GCD. If you know the GCD, right? There's a direct function underscore GCD, right? To calculate the function, is the inbuilt function. You can just divide them. Basically, LCM equals to the product of two numbers and by GCD, right? So this was the initial approach I thought, and okay, that's very simple. Break even when GCD equals to 1. So I just implemented that. Long private started with 0. I started with I equals to 1. And then I check the current GCD, the previous whatever we calculated. And this you have to do with a long. Why? Because you're multiplying two elements and dividing at the same time. It ensure that this whole division would be in 10 power 8 range, but it could happen right like that, right? 10 power 7 into 10 power 6 upon 10 power 5. Overall result is 10 power 7, not 10 power 7, so 10 power 8. 10 power 8, yeah. But you try to understand, right? We overflow this numerator. So that's why it's better to use long. Don't confuse with that thing. You have to use long because it could overflow. There are ways to solve it, but it's a easy way to solve it. Use long, right? When we computed also, we have to do multiply one long with here because both the numbers should be in the same data type. Prev is of long. This also should be of long. I made it to typecast it to long. And I did that, and elsewise usually becomes one. This is a breakage point. Push the previous prev, whatever you computed, and then you push the nums of I. That means it's not push the nums of I, reset the prev to this, and then this. Most of you have thought about it, and it passed 61 out of 70 test cases. It was amazing, but it was wrong. Why? Let's see an example. Interesting example. Why approach fails. So if you see about it, oh, you found 2, fine. Prev is 2, fine. Then you start with 3. Oh, there is GCD is 1. Okay, that means I have to push 2. Fine, no problem. Then I go about 3 and then would check, oh, 3 is prep, fine. I won't push it until then. Oh, 3, 6 is there. GCD is what? 6 itself. So it becomes 6. Now I move forward, but there is nothing remaining, so I have to push the last element. But our final looks like this. But is it the final answer? Think about it. It's not right. We can still further reduce it to 6. That's the problem here. Is it is not we are just focusing. We're not focusing on the complete thing. We are just focusing, oh, it could happen. We are not further focusing on the future elements, right? We are just stopping by whenever we find a GCD equals to 1, but that's not the case. It could happen that from the right side also, it takes some contribution could be there, right? This is wrong. Then, oh, now we are back to the zero again. That, oh, you told this is a easy problem. You solved me a wrong approach. Why you told me the wrong approach? You wasted my time. No, you have to think about it. You should not think like that, right? You make mistakes, right? It could happen. Then how to recover from that point? Now, let's try to think about that. What we actually want to do. See, we will take the same example. The problem is happening was we have to take about future elements as well. And what is the problem? Like our initial approach is slightly fine. There's no problem and no harm in that, but just that we should not push it immediately. That's the entire difference. Push should not be immediate. We should wait for that. We should wait for that. And what did you remind something of that? Because the order is important. The order is important here. So our thought process initially was same. The combined approaches of both the problems is okay. What do you think about it? Okay, process should not be immediate, but we are deleting the topmost element only. We are sorting keep of some top or previous element. What did you remind of something? Reminding of your first stack, right? Stack. Oh, stack. Now I'm getting some sense. What I will do? It's very simple, yeah. Push two into the stack. Fine, no problem. Then you find check whether this have and this I have a GCD or not. Oh, they don't have a GCD. No problem, yeah. Push into the stack. Push into the stack. Now you won't push it immediately into your final answer array. That you will do at the end. I will tell you how. And then you find 6. Oh, let's check with oh, there is a match. Yes, there is a match. So what you gonna do? You will just push 6 here. Then you again check, keep on checking until you find a match. Oh, there's again a match. It would be 6. Here, that is the difference between the original and previous one. We are caring about the next element also because we are not immediately pushing, right? This is the entire and intuition with difference between. In a way, we are just traversing our array two times and it's O of 2n solution. It's not a O of n square type of solution. I hope you're understanding. We are just visiting each element twice itself, once in stack in the reverse order and once in the forward of the iteration. And that's that simple question it is. It's that simple, yeah, that simple implementation. What do you have to do? The simple algorithm, right? You just initiate that push the first element in your stack. That what you gonna do? You gonna do while obviously your size should be greater than 0. It should not be empty. And add GCD of, this is the standard way of calculating the GCD of s dot top and your current num. Now you will update this num so you can define this num. Here you are inside a loop. Num is equals to nums of I. This is the initialization step. This is the initialization nums of num. Why num? I will tell you because see, it will update, right? Keep on updating. So what we'll do, we'll update num with the LCM. With the LCM. So how do we calculate LCM? It's just the num into our current S dot top divided by the GCD. GCD. Cool. And then we gonna keep doing that until we found the number which has GCD equals to 1 or size becomes 0. Obviously, we're gonna do a top as well, pop as well. And then what we're gonna do, we're gonna push this num into our stack again. And the important thing is we are not immediately pushing into the final answer vector. That's the entire difference. And then what we're gonna do is when this entire thing ends, we'll just write while this after I perform all operations. I found all operation. I found my stack file as .empty. I just push all the elements of the stack into our answer vector. Answer dot push back as dot top and as dot bottom. Now, what's the wrong thing here? Can you tell me? Can you tell me? Can you think about it? Yes, you thought it right. So reverse it. We have to reverse it because stack pushes the element in the reverse order, right? So that's the entire intuition. That's the entire thought process of the code. That's we just you quickly walk through the quickly code. It's very easy. It's very simple. Initialize the stack with a long again. And then what we did, we just pushed the first element in the stack. Then we start from I equals to 1, right? And then we calculate the current num. Because we want to update it, we will separately we initialize another variable num. And then we will check until the size is empty, or you keep checking, or it should be greater than 1. GCD of s dot top, num is greater than 1. It keep popping out, and we keep checking the GCD, right? And then what you're gonna do, we just push this num when the GCD of the top and the num what we are currently updating, because see, this is updating with the LCM. It keep updating. Now what is happening, 2, then 3, and then it came 6. It will pop 3 as well, and it will pick 2 6. Then it pop 2 as well, and it will become 6. This is happening, and eventually we are pushing only lefting with 6 only in this here after the while a for loop. And then let's just keep pushing into our final answer vector, reverse this answer vector. This is the answer. So this is pretty straightforward, pretty good question, interesting, easy question. This kind of question comes, right. You have to solve these kind of question. You cannot ignore them. These are not hard. Yeah, this is easy. Tell me in the comments if it was found it easy or not. Right. So yeah, this was it. And if you like the video, keep hit the like button, subscribe to the channel if you're new to the channel, and also check it out the way series as well. Stay tuned and for further updates.